Checkpoint 6.29. They want us to find the potential function for f, which is equal to 12x, comma 12x squared, comma cosine y cosine z, comma 1 minus sine y sine z. All right, we will assume that this is a gradient field, and that means for each of these things, each of these components is a derivative of something. The first one with respect to x, the second one with respect to y, and that last one with respect to z. So to find our potential function, we will do the antiderivative of, for the first one, antiderivative of fx with respect to x. So we'll integrate 12x squared with respect to x, and that will equal to x cubed over 3 with a 12 there, so the 3 and 12 will cancel. That will give us a 4x to the third power. Now we have to allow for constants with respect to x, so this could possibly be in the form of a function with a y and or a z in it. So if we take the derivative of this function g of yz with respect to x, that will disappear, and all you will have left is the term with the x. Now let's take the same idea, and this time we'll take the second function, assume that that was a derivative with respect to y of the potential function. So we want to take the antiderivative of cosine y cosine z with respect to y. Z is a constant, and the derivative of cosine is positive sine y times cosine z. And again, we want to allow for a function of x and z to happen, because with respect to y, that'll disappear and that'll be constant. Finally, that last function is a function with derivative with respect to z. So we will assume that if we integrate that with respect to z, we would get the potential function. So we have a 1 minus sine y sine z dz, and the antiderivative of 1 is z with respect to z. The antiderivative of sine y sine z with respect to z. Sine y is constant. The integral of sine z is negative, so that'll change this negative into a positive. Sine y is constant. The derivative, or the integral of sine z, is negative cosine z, and we want to allow for our function of x and y if it exists. Now, if I do some comparisons here, I see my x 4xy cubed, which probably could fall into here as a function of x. Now I also have sine y cosine z, which corresponds to this sine y cosine z. And finally, I also have my z, which would fall under the category of a function with respect to z. So I think if I collect all these terms here and don't do any duplicates, we can have f of x, y, z to be equal to 4x cubed plus sine y cosine z plus z, and then throw in a constant there for good measure, and here is your potential function. Now you can double check yourself, I'm not going to, but if you take the gradient of this function, you should get the original vector field that we started off with. All right, I hope that helps.